All right, we're going to solve exponential equations, and let's review some concepts, and that is log base 2 of 2 to the x is log base 2 of 3. If we had this equation, then we would know that x must equal log base 2 of 3 because the left side simplifies to x. And another concept to review is write 8 in base 2. So if we want to have an equation, write 8 with a base of 2, we have to figure out what the exponent would be to create that. So there's base 2. And let's get started. All right. So a quick strategy here is to make sure we have the same bases. And we have an 8. So let's just say that 8 and 32 can be rewritten with a base 2. 8 in base 2 is 2 cubed. 32 in base 2 is 2 to the 5th. We're just replacing the 32 with 2 to the 5th, and then we can work on the exponents. So now we have 2 to the 3x plus 12 equals 2 to the 15x. And if we have the same base, then the exponents must be equal, and we can just say that that's true. Subtract 3, and we get 1. All right, so over here, rewrite these with base 3. Pause and try that one. Minus 4, minus 15. All right, and pause and try these. We'll go with a base 2. minus 2x plus 5. And over here, let's make this have this base. We can't change that, so we'll leave it the way it is. But we can do this. Let's do 25 over 36 to the negative 1. So we just did the reciprocal. Now we can work on getting that to be a 5 and that to be a 6. And that is squared, so we'll have a negative 2. Negative 18 plus 2x. So we have 4x equals negative 18 plus 2x. Minus 2, negative 9. All right, so we have a different strategy here because we're not going to make this have a base e. Here we have base e, and with this one we're going to isolate the exponential, so we'll divide by 3. And to cancel the inverse, to use the, to cancel e to the 4x, we're going to do log base e of x. So that would be ln of e to the 4x, natural log of 15. Now remember, natural log is log base e. Okay, pause and try this one. All right. And if we didn't have base e, we still want to isolate the exponential. So we're going to add 1. And up here we did log base e because we had base e. Here we have base 8. So let's do log base 8. And here we have different bases, so we'll just have to use log base 10. We could do natural log or log base 10. So let's just do log base 10. As long as we have the, we don't have a coefficient here, we can do log of both sides. And use the property of a logarithm to move that in front. we need to get the variables on one side, so we have to distribute. Distribute log of 7 to x, log of 7 to 1, log of 11 to x, log of 11 to 1, and let's get the x's together. So I don't want the x over here, I subtracted it here, and I don't want this log over here, I'm going to subtract it over there. Log of 7 minus log of 11. And then we'll factor out an x. So we want x by itself. Let's divide both sides by this, so it ends up under there. And we can simplify that. If we look at this as factoring out a negative, we would have that. And now when we go log plus log, it's going to be negative log, and that's 7 times 11, because addition changes to multiplication. Here we have division, subtraction, so that will turn into division. And if we do that on the calculator, we get approximately negative 9.61. All right, pause and try that one. All right, distribute. And then we're going to get the x's together. Let's move this x over to the other side. Move that to the other side. Add log 8. Factor out an x. And divide by this. And we could simplify this to be, move the 2 up there, it'll be a 25, 25 times 8. So the numerator is log 25 times 8. And here we'll have Move the negative 2 up there to the exponent of 8. That'll be a 1 over 64. 1 over 64 times 5. 5 over 64. Approximately 2.08. All right. So now we're going to look at these as quadratics. And once you see that this is twice that, then we will write it as e to the x squared, e to the x then we see if we say, let's just say e to the x equals u. U is e to the x. So now we have 9u squared minus 3u. And we simplified it to something more familiar. This one we can divide everything by 3. And to factor that, we could use negative 2 times 3, negative 1. What multiplies to get negative 6 and adds to get negative 1. 3, 2, negative 3 times 2. When this is not a 1, then put that in first, put that in last. These numbers go in here. And we factor out a negative 1, u, 3, u, and a 1 at 2. So 2 times negative 1, 2 times u. These all work out. So now we have the factors, 3u plus 2, u minus 1. 3u plus 2 is 0, u minus 1 is 0. All right, and then we remember that u is e to the x. Okay, solving for x, if we did natural log of both sides, this is imaginary, is a non-real. You can do a natural log of a negative number, it's just imaginary. And here we're going to have natural log of 1 is 0. So the solution is 0. Pause and try that one. Just see that the 8 is twice the 4, and that'll allow you to use a similar strategy. One more hint. In this one, you use e to the 4th instead of just e, or e to the 4x. So our goal is to make it a quadratic. And if you see that there's an 8 there, we're going to use this strategy. That must be a 2. 2 times 4 is 8. And then you just make this be whatever it has to be to match up with that. So that's u, 2u squared. And we'll factor that. And we're going to have 2u minus 1, u plus 1. And u is e to the 4x. Do natural log. Okay, that's going to be imaginary. And over here we'll have we can write it like that, with x being approximately negative 0.17. Okay, I'll stop there.